Hello everyone. Good evening. So, can I get a confirmation in the chat box whether my voice is clear and loud enough? Hi, Rishit. Hi. So, how was your today's problem of the day? How was your experience with the question? Was it good? Yes or no in the chat box? The question was pretty easy, I think, as well. Okay, so we'll be waiting for like few minutes more, like 1 minute more, and then we'll be starting the session sooner. So, what about the confirmation? Can I get a confirmation? Okay. And what about the problem of the day? How was the problem of the day? Were you able to solve the question? A quick update on the uh, problem of the day. Were you able to solve the question? How many of you are able to solve the question? Okay. So I think we should start the session. Just let me share the screen. Okay. Okay. So it's 21st March, the problem of the day, and the name of the question was taxi booking. And let's see the question, and the difficulty level of the question was pretty easy. Is it the thing that everyone thinks that the question is easy? What do you think? What about the difficulty level? I want to know from everyone. Like, I think the problem of the day, the questions that are given to you, I think they are very finely chosen one. Don't you think? I myself enjoy the problem of the day. Yes or no in the chat box, and then we'll be quickly moving towards the problem. Just a minute, we'll be starting soon. Okay, so let's read out the problem statement. And the name of the question was taxi booking. So you are going to book a taxi, and there are infinite number of points 1, 2, 3 on the x-axis. And your current position is given to you in the question, and it is denoted by current. And there are n taxis near you, and the position of this taxi is given to you by an array which is called array, and the name of the array is called position. And at every index it denotes that what is the actual position of the taxi on the x-axis. And along with the taxi location you are given the time that ith taxi will take defined amount of time in order to cover 1 unit of distance. So time of I denotes that ith taxi is going to cover 1 unit of distance. And what is the task? The question wants you to find the minimum time to board a taxi. That in what minimum time among all the taxis I'll be able to catch a taxi. Okay, so that was the problem statement. And any doubt with the problem statement? Yes or no? Yes, Gopikant. It was a pretty easy question. Yes, the problems are good. I agree myself as well. Okay, so we'll begin. We'll start with the explanation of a test case. So over here, in the question you are given n is equal to 3. That means there are n number of taxis and your current location is given to you as 4. And the positions are 156 and time is 231. So these are the positions of the taxi. This will be called the position array and this will be called the time array. Okay, and let me write down the indexes as well. 0, 1 and 2. These are the indexes of the taxi as well. This is an array. So let's draw a number line as well. So we'll be getting let's say this is our number line and this is our x-axis. This is 1, 0, 1, 2. These are the coordinates of the x-axis, right, and so on, right? It will be an infinite. So now over here, let us first of all denote our position. So we are denoted by 4, and this is the variable which denotes our position, current. So currently we are standing at this position. Okay, and let's denote the positions of the taxis. So 0th index contains the position 1. So over here there is a taxi on 5th as well and on 6th as well. So these are the taxis available, and there are some time associated with the taxi, that this taxi is going to take 2 unit of time in order to cover 1 unit of distance, and this taxi is going to take 3 unit of time in order to cover 1 unit of distance, and this is going to take 1 unit of time. Okay, so now we have to find that which taxi will be reaching us in minimum amount of time. Is the question clear? Yes or no in the chat box? A quick yes or no. Okay. So over here, how to find that which taxi will take what amount of time? So over here, what we can do, we are given that for ith taxi, the time taken will be Ti. Ti is the time taken in order to cover what distance? 1 unit of distance. So what is the distance between you and the taxi? The distance between you and taxi is currently 3 units, right? The distance is 3 unit of distance is there. So what do you think, what will be the time taken? So it is a simple cross multiplication, and then you can find out that what will be the time taken by the ith taxi. So let's find out the time taken for each and every taxi. Is it clear what we are doing right now? This formula, is this formula clear? This is a very basic formula, a cross multiplication. We already have done this in our school as well. Simultaneously, if I'll be getting a response now, I'll be knowing that okay, so I'll be moving forward quickly. Rishit, can you give me a confirmation in the chat box? Yes or no, a quick confirmation. Because this formula is the key of solving the question. This formula is the key of solving the question. Okay, Rishi, thanks. So over here, this is the formula, and now let's find out the distance. Let's find out the time taken by each and every taxi. So this taxi is at distance what? 4 minus 1. That will give me the distance between us and the taxi. That is 3 units. So now what I need to do, that in order to cover 3 units of distance, what will be the time taken by the taxi? A simple cross multiplication. The taxi takes 2 unit of time in order to cover 1 unit of distance. And currently, what is the distance? 3. So cross multiplication, 2 into 3 divided by 1, that will give me 6. Okay, so this taxi is going to take 6 unit of time. Similarly for this, what is the distance between us and the taxi? 5 minus 1 is 4. And the time taken to cover 1 unit of distance is 3. So for 3, it takes 1 unit of time, or 1 unit of, let's say, 3 units of time is taken to cover this much of distance, and now distance is 1. So what is the time taken? Over here, it comes out to be 3 again, the number itself. And for this, we can do a simple cross multiplication. The time taken is what? The time taken to us is 4. The time given over here is 1, and distance that will be covered in 1 unit of time is 1 distance, and our distance between this taxi is 4 minus 2. That will give me 6 minus 2. 6 minus 4, that will give me 2, and the cross multiplication gives me 2, right? So it will be taking 2 unit of time. So now from this, what is the minimum time? Which taxi, or let's say, what do you think that what is the minimum time in which I'll be getting a taxi? Among all the times written over here, what do you think? Which taxi, what will be the minimum time taken? What do you think? These are the time taken by taxis in order to reach our location. So minimum is obviously among 6, 3 and 2. The minimum comes out to be 2, and here for this the output is 2. Taxi at index 1. Index minus 1? No, not index minus 1. Where do you see a taxi at index minus 1? This taxi the taxi present at the last index, this index. This taxi, index 2, will be taking the least amount of time, and that time is 2 units of time. Okay, so this was how we are going to solve each and every test case. Is the explanation of test case clear to you, how we can solve the test case? And from this we'll be directly able to solve each and every test case. A simple formula needs to be defined in order to solve it. I think it is pretty clear. Okay. So now based on this, can you give me an approach? Can you give me an approach? For this question, I think the audience will figure out the entire solution. It's that simple. The question is that simple. So from this, what do you think can be the brute force approach? A single line statement can be given after knowing the formula or knowing the way to solve a test case. A single line answer. What can I do? What do you think? With the help of this formula, I can figure out the entire solution, and the way we solved the test case is our solution. So over here, what we did, we were finding the time taken by each and every taxi, that in order to reach our location, what is the time taken by 0th index taxi, index number 1, what is the time taken, and the taxi at index 2, what does it take. Find the time taken by each taxi to reach our current and take the minimum. Yes, exactly, Rishit. Yes, this is the solution. It was that simple. So what do you say, what is the paradigm of solving this question? The technique which we are using over here is called greedy algorithm. We are choosing greedily. How? We are taking the taxi, we are taking the time which is minimum among all the time taken by the representing taxis, right? So this is a greedy technique. We are finding simply the minimum among all the values, and that is our answer, right? Minimum and maximum, finding minimum maximum, that is under greedy. So a single line statement was given by Rishit, and that's exactly correct. So that is, we need to find the time taken by each and every taxi. Find the time taken to reach our location by every taxi and choose the minimum value. Yes. So for this, what do we need? We need a simple formula. So over here we were doing the cross multiplication. Okay, so let's generalize this formula. The cross multiplication was between which values? So over here, the Ti is the time taken by ith taxi in order to cover 1 unit of distance. And currently, what is the distance between the ith taxi and current position? So that would be current minus position of I is the distance between the ith taxi and your location. Is this part clear? The ith taxi is at a distance, current my position of I. Is this formula clear? This formula. That this is the distance between the ith taxi and current. A yes or no in the chat box. We should. Yes, we should do that. But this is the formula, that this will be the time taken. This is the distance. Exactly, we should do absolute value because we aren't sure that the taxi is present at the index after us or not, at a position greater than its value, greater than our location or not. So we should always take the absolute value. That's exactly correct. We should take the absolute of it, because distance cannot be negative, right? And we aren't sure that which is going to be greater. Either current is going to be greater or position of I is going to be greater value. So this is the distance. So over here I'll put the formula current minus, let's write down the absolute as well, absolute of current minus the position of ith taxi. And from this we were doing a simple cross multiplication, and this was divided. So that would be t of i multiplied by the absolute value, which you will be getting absolute of current and the position of the ith taxi, divided by 1. A simple thing we can do this way. Division by 1, we already know this is not going to give us anything, right? So this is the formula which will be used to find the time taken by each and every taxi to reach our location. So we'll be applying this formula for every value, every ith value for every ith taxi, and then we'll be taking the minimum of all the values to whoever. Okay, that was a good message from Swarup as well. Yes, I can see many of you guys are constantly, like, they are consistently doing problem of the day. They are actively. I have taken like almost 3 or 2 to 3 session over here. So I can see they have been constantly engaged in solving problem of the day every day. So that's a really good practice. Okay, so I really appreciate those of you are uh, doing it daily. That's a really good thing. Keep on doing daily, and your problem solving skills will be very sharp at the end. Okay, so can I know how many of you are doing it daily? I can see Rishit is replying every day, so I think he is doing every day. Can I know how many of you are doing it daily? Okay, so I'll be reading out the replies afterwards. Okay, okay, nice, good, Rishit. So this is the formula we'll be applying on every ith taxi, and then we'll be taking the minimum value. So we can write down a pseudocode directly as well, or we can write down the algorithm first. So let's write down the algorithm, and the pseudocode will be easily figurable. So what we'll be doing, we need an answer variable that will store the minimum time taken. So let me initialize the answer variable with infinity, because everything is going to be smaller than infinite, right? So now what I'll be doing, I'll be running a for loop, or let's say I'll be needing to find the distance, needing to find the time taken by ith taxi. So I'll be writing iterate over every taxi. So while iterating, I'll be finding the time taken, let's say a temporary value, or the time taken by the ith taxi. So time will be nothing but this formula, ti into absolute of this value, t of I into absolute of current minus position of I. And I'll be taking the minimum of all the temporary values. So I'll be comparing it with my answer variable, and every time I'll be taking the minimum value and assign it to answer variable. And these two statements are a part of the iteration. And at the end, you can simply return the value of the answer variable. So this is the entire algorithm. Is it clear? Yes or no in the chat box? Okay. So let's discuss the time complexity here only. because we'll be simply needing to add the syntaxes in whichever language we need to code this algorithm. So if we talk about the time complexity, let's say this iteration over here, I can see an iteration. So what will be the time taken by this iteration? So this iteration is iterating over all the taxes. So how many taxes are there? According to the question, there are n number of taxes. There are n number of taxes. So this loop will run n number of times. And inside the body of this iteration, do you think any of the operation is greater than big O of 1? No, this will be taking constant time. This will be taking constant time. So the overall time complexity of this algorithm comes out to be order of n, that is linear time complexity. And if I talk about the space complexity, I cannot see anything space which is depending upon the size of the input. No space is required that will depend upon the test case. So the space complexity over here comes out to be order of 1, and this is our time and space complexity respectively, order of n and order of 1 for the given algorithm. Okay, is it clear, the time complexity? I think I don't need to discuss very deep in the time complexity because it is pretty observable over here. So now let's try to code this part and we'll be solving it over here. So I'm writing the code in Java, but the same thing can be implemented in other language. It is that simple. A simple integer variable is required that will be storing the answer, and that would be initialized to infinite. So I'll be taking the maximum value of integer variable of integer range. And now I'll be iterating over all the elements. All n number of iterations is required. That is n number of taxes. And now I need to find the time taken by ith taxi. So the formula was time of ith taxi into the distance, the absolute distance, absolute difference. Math.abs will give me the absolute difference between current and position of I. The difference between current and position of I. And simply compare it with your answer variable. If answer is, let's say, if temporary variable which you got is lesser than your answer, then what I'll be doing? I'll be assigning temp, else I'll be keeping answer as the assigned value as it is. And see, over here, we simply need to return the value of our answer variable, right? And let's try to submit it. Okay. So there is a dot over here. I don't know why did I do this thing. Okay. Okay, so the name is CUR, not CURR. Okay, so the compilation was completed and let's try to submit it. And the problem was successfully submitted. Any doubt in the implementation part? I think the implementation is pretty straightforward. There won't be any kind of doubt, I think. But if you have, so I'll be waiting for 1 minute. Any of the question from your end, I'll be more than happy to answer all of your question. So yes, so I'll be waiting for a few minutes and then we'll be ending this session. So if you uh, get any kind of doubt in that 1 minute, I'll be solving it. Can you discuss the SC again? Space complexity. Okay. So the space complexity over here, this is our algorithm, and we haven't used. Okay, so just a minute. Okay, so we haven't used any of the auxiliary space that depends upon the size of your test case, right? The answer variable, whatever is the size of your test case, let's say there are n is equal to 100 or n is equal to 10,000 or anything, the answer variable is going to be only one, and there is nothing extra. This temp variable is also going to be constant for every size test case, and hence the space complexity comes out to be constant. Was it clear? Okay. So I think no one is having any kind of doubt. So we'll end the session over here only. And can I know that do you guys really enjoy solving POD, problem of the day? Okay. So I think everyone. Okay. So we'll be ending this session here only. So it was a great solving this question and it was great interacting with everyone. So thank you everyone. Good night. Bye bye. Okay, Rishit. Fine.